Chemistry Cram. Let's master this week's practical in under 10 minutes.
Experiment 1.1 Melting Point and Mixed Melting Point. The melting point is the most widely used physical constant for solids, and there are several reasons for determining a compound's melting point. It is useful in consolidating the identification of a compound, as well as helping to form a guide as to the relative purity of the sample. Due to being a physical constant, substances can be roughly identified using their melting point range. If you find out the melting point of a mysterious substance, you can compare this value to the literature melting point in a reference book to find which substance corresponds to their experimental value. Of course, this doesn't guarantee that your substance has been correctly identified, as there are millions of solid organic compounds around us, and most have melting points below 250 degrees C, so you're likely to discover two completely different compounds with almost identical melting points. As a result of this, it is fundamental to use experimental melting point values as only one piece of data to support the identification of an unknown substance. The second reason to determine a compound's melting point, though, is for a rough measure of purity. In general, impurities lower and broaden the melting range. Because of this, you must report a range of temperatures over which the melting point was observed. You will lose marks if you don't do this, so it's worth remembering now. For this week's practical, you have two main aims. The first is to find the melting point of an unknown sample through comparing it with the literature melting points in the lab manual. The second aim is to identify the unknown sample. You'll need a sample of both compounds to do this, and a little bit of mixing prowess in order to achieve it. We will then use the purity to determine the name of the compound. The main fact to take away from achieving these two aims is that both were achieved through finding the melting point alone. It just goes to show how useful this value really is. This is a rather foolproof experiment when it comes to safety, but as always, safety must never be overlooked. So have the following things at the forefront of your mind throughout the entire practical. Do not leave used melting point tubes on benches. Instead, dispose of them in the designated labelled beakers. Always wear goggles whilst inside the lab. The melting point apparatus will obviously get very hot when heating a substance to its melting point. You may have to keep heating until upwards of 165 degrees if you are given a certain substance out of the group. Be vigilant and give the apparatus the respect it requires. Stay safe during your practical. You probably have many more to come. So, let's begin. The first step is essentially checking to see that your heating apparatus is working correctly, and that your technique of finding the melting point is superb. To do this, you'll need to determine the melting point of a carefully purified sample of 4-chlorophenyl ethanamide, which your demonstrator will give to you. You'll be shown by the demonstrator how to cut the capillary tubes and also how to fill them with substance. This will be your opportunity to practice before attempting the two main aims of the practical. Here is exactly what you'll need to do. Set your plateau temperature using the fast stage set button and set the heating rate at 2 degrees per minute. Your instructor will have shown you how to do this. Heating at a slow rate of 2 degrees a minute is recommended for accuracy. Prepare a capillary tube with your sample and place it in the machine. Press Start on the machine. The unit will heat up until it starts beeping. Press Start again to stop the noise before others around you get slightly annoyed. The machine will now start heating slowly. It's up to you now to identify the melting point range, and note this down immediately once you've gotten it to stop you forgetting. And that's pretty much the gist. Now for the meat of the practical. Get your unknown sample from your demonstrator by showing you've completed the last step. Use what you've just learned to perform another melting point determination on this sample. By looking at the list, you will find two compounds that have melting points similar to what you've just found. The next step is to find which of the two your sample happens to be. Obtain both possible samples from your demonstrator. You'll now need to make some mixtures. You can make a mixture by crushing together small and equal amounts of the two compounds on a clean and dry watch glass. You'll need to make 4 last tube samples, which are as follows: a mixture of unknown A and the first known compound of the pair, and just the first known compound on its own. Then you'll need a mixture of unknown A and the second known compound of the pair, and just the second known compound on its own. The first two and the second two should be performed side by side for best accuracy. But how do I know which my sample is? It's actually really easy. If the first melting point comparison you make yields 2 identical melting point results, for example, your sample is the first known compound of the pair. This is obviously assuming that the second comparison yields 2 rather different melting points as a result of the impurities in the mixture, being 2 different compounds, changing the range of melting. Use your reasoning and deductions to write a short conclusion in your lab book, proving that you've correctly identified your compound. If you're right, congratulations, you've finished today's practical. Remember that only a very small amount of material is needed for melting point determination. You don't need to waste time by grinding more than necessary. Lastly, and most importantly, always quote a melting range. Seriously, it's not worth losing marks through forgetfulness. For this experiment, you do not need to complete a proforma. Instead, you are required to complete a quick multiple choice test to prove your knowledge and aptitude at performing the practical. The questions relate heavily to the content of the practical and the results you obtained. Remember to read each question carefully and don't press finish until you are sure of all of your answers. Some answers can be determined from the content of the lab manual as well, and some will need your working out to accomplish. But as far as post-practical assignments go, this multiple choice test will not take you very long at all. Here are a few questions just to help your brain get rolling a bit. What is the recommended heating rate for the slow speed setting? Is it 3 degrees, 2 degrees, or 1 degree Celsius per minute? Melting point determination is useful for which of these? Determining the colour of a substance, determining the polarity of a substance, or determining the purity of a substance. Where should you dispose of capillary tubes that have been used? Is it the floor? Is it in paper bins? Or is it in designated glass beakers? Now hopefully the Oadby bus has just pulled up outside the university. This has been your 5-minute chemistry cram. Good luck and enjoy your practical. I'll see you next week.